Welcome to our German time afternoon session for this expert workshop on SIQuench, arc quenching for medium voltage applications. You out there will hopefully receive valuable information for you. It is around a state-of-the-art solution in the range of proactive arc effects mitigation measures going beyond the safety currently set by the standards. And as of today, may the force be with us. You've probably seen that I'm not Princess Leia, but my name is Michaela Mönikes, and I am happy to be a moderator for this webinar. Some of you might already know me. I've given guided tours on the Siemens booth, be it virtual or live, and you might know me from our former electrification and automation webinars. And if not, this is the first time you meet me, that's also okay. I'm giving you a virtual tour through this webinar for SIQuench. We will start with internal arc faults and their consequences. Then you will receive an introduction to arc quenching in medium voltage systems. You will get to know the system components and their benefits. Support for decision making will be part of the presentation, and surely you will have the chance to address your questions to the experts. And since we receive one question rather often, the answer is already yes. We do record the webinar, and we will make the recordings and the slides available to all the registered participants. If you already joined one of our last electrification and automation webinars, you know the Q&A field in this application. The question and answer field, I think in your case it's just the questions field, is there for you. Please type your question to the presenter and I will be your voice and ask Kerem directly after his presentation. And in addition to me reading aloud your questions you put in the questions field, you could also chat with our expert here in the background. During the presentation, he will try to give short answers in the chat. And please be aware of the following limitation. The chat is available in live mode only. The question and answers questions will be answered via mail if we do not manage to answer all of them during the live session. And now let me introduce our experts. Right here in the studio with me is my dear colleague Kerem Bayram. He is the product manager for air insulated switchgear medium voltage primary. And with his expertise in medium voltage switchgear, Kerem will shed light on the SIQuench components and the benefits. And then we have Deat Hashtelen. He will take care of the chat, and with his expertise on medium voltage air insulated switchgear, he will try to answer your questions in the background. But Kerem, as we are now curious to learn about SIQuench and we want to dive into arc quenching for medium voltage applications, Kerem, the stage is yours.
Michelle, thank you for the great introduction. I would like to welcome all our attendees. My name is Kerem Bayram. I'm one of the product managers for medium voltage air insulated primary switchgears of Siemens. During today's session, I would like to introduce you a state-of-the-art solution in the range of active arc effects mitigation measures. The occurrence of an internal arc fault in a well-designed, type-tested, correctly installed, and operated switchgear is improbable, but not impossible. The reasons are mostly linked to human interference or environmental causes. Most repeating causes are loose connections, corrosion causing overheating and further escalating to arcing faults, rodents and vermin entering into the equipment, or deteriorating insulation in time. Many of you should have seen kind of disaster videos showing arcing faults and their consequences over human beings or on the equipment and its environment. What you have seen there is an explosion with a dense light and fire and smoke. What happens inside the equipment remain behind the scenes and actually beyond those you have seen. Here we are talking of temperatures exceeding the sun's. Copper in the thermal phase expands by a factor of 60,000 times when it transforms from solid state to plasma formation. The high pressure, which can easily rupture eardrums and collapse lungs. The level of sound associated with the pressure, which can exceed 160 decibels. Material and molten metal expelling at speeds exceeding 1,000 kilometers per hour, fast enough for a shrapnel effect to human body. Accordingly, possible consequences on the equipment, processes, and human beings are various. An internal arc classified switchgear can prevent operator injury under normal operating conditions, which is the status where all doors and covers are closed as per IC. But it does not protect the equipment from damage and prevent the occurrence of secondary hazards like pressure wave, sound blast, blinding light, fire, toxicity, contamination, and etc. And coming back to the definition of normal operating conditions, this is not always in line with the necessities of real life, right? Just imagine a simple maneuver when a high voltage door is opened to take the circuit breaker out of the panel for a periodic maintenance or for interchanging it with one of the other feeders. And as expected, the bus bar should remain live. This is what an LSC2 type service continuity category offers for. So what about the safety in such status? In the case of an internal arc, priorities are clear to every of us. First is to protect the personnel, as it may endanger their lives. Second is to keep the equipment and related processes available, as it may lead to substantial economic losses for the businesses. System engineers are in a dilemma. They should find the optimum balance in between the best possible coordination settings to minimize the effects of unplanned shutdowns and the best possible safety of personnel. And each usually means sacrificing the other. Within this dilemma, there are some parameters already fixed without room for adjustment. In regard to limiting the arc flash incident energy, there is also not much room to play. Amongst the parameters, it is the fault clearing time we can act on by utilizing fast tripping circuit breakers and early detection of arc via light or pressure sensors. But what if we would have the chance to act directly on the arc itself? We have a solution. Quenching the arc itself in 5 milliseconds after ignition of the arc, preventing the damage to the equipment due to arc flash, uncompromising safety even when the doors, compartment covers are open, which is reusable, a unique feature allowing to restore the service in a very, very short time without the need for replacing the equipment and the switchgear it is located in. You'll be watching a short video now demonstrating this solution in a nutshell. Then I'll be back.
Arc flash faults are the most devastating events in power distribution systems. In well-designed and type-tested switchgear, internal arc faults are unlikely, but not impossible. Mostly, they are linked to human interference or environmental causes. Typical internal arc classified switchgear can prevent operator injury under normal operating conditions. However, it does not protect the equipment from irreparable damage and does not eliminate all the secondary hazards caused by an arc flash. The damage causing power supply and process disturbance may lead to substantial costs of millions of euros. The solution from Siemens is SIQuench. It is a reusable active arc effects mitigating system, quenching the internal arc in sub-cycle times. In the event of an internal arc fault, it reduces the system repair time from days and weeks to minutes and hours, resulting in drastically reduced economic losses. Conventional protection methods do not provide fast enough protection capable of securing the assets, the safety of staff, and the availability of the processes. Once an arc fault is detected, SIQuench, at almost the same time, consciously closes the main current path of the switchgear to Earth. This creates a three-phase low-impedance parallel path for fault current to flow, thus extinguishing the arc fault right away. The internal arc is quenched in less than 5 milliseconds after ignition, long before the pressure peak and before the arc can cause any significant damage. It minimizes the damage within the switchgear due to reduced arc energy and pressure. Service can be restored rapidly, leading to minimized service outages. SIQuench offers a state-of-the-art level of safety that goes beyond the standards. It minimizes repair costs. The faulty functional unit of the switchgear can be used again. It is reusable, capable of quenching 5 times without the need for replacement. And it is maintenance-free. SIQuench offers constant reliability through continuous self-monitoring. It also has the capability to switch for testing and commissioning purposes without the need for replacement. SIQuench, taking your switchgear to a higher level. It is available as a complete solution for Siemens switchgear. Siemens SIQuench, your natural choice.
So, SIQuench, in the case of an internal arc, by consciously closing the live bus bar over the ground bar of the switchgear, it creates a controlled, bolted short circuit path for the fault current to flow. This is the main current path of the switchgear and is actually the intended current path for such fault conditions. And it does that within 5 milliseconds after the arc is first ignited. By doing so, it prevents the damaging effects of an arcing fault and allows to re-energize the switchgear in a very short time, avoiding time-consuming and costly system repair activities. Words are meaningless when it comes to arcing faults. Here you will watch a video shot from one of our development tests with SIQuench located in the busbar compartment of a 12 kV lineup. Arc ignition was in the cable compartment of the cubicle in the middle. Not that fancy, right? You see nothing, because the arc was quenched immediately after it ignites. Primary and secondary hazards are fully avoided. And the result, compared to the one without SIQuench, for the same fault current. The blackish points on the cable termination coupers were the arc ignition points. No damage has been given to the panel when SIQuench is used, and the same panel can be re-energized immediately after deleting the root cause of the fault. Arc fault is sensed by an arc flash protection system acting on light and overcurrent, which are the standard characteristics of an arc that make it safely detectable. We not only rely on light, but await for an overcurrent signal which is above the set current thresholds. When those two indications are available at the same time, only after then SIQuench is activated. By doing so, nuisance activations due to external disturbances are avoided. SIQuench has a unique feature. It is reusable, or we can call it as resettable. So the switching operation in the case of an arcing fault is reversible. Resetting is done from front of the panel without the need for opening any covers or even any doors. It can withstand 5 consecutive switching operations with the full rated short time withstand current of the switchgear. It also allows for 30 real physical switching operations without load for testing and commissioning purposes. SIQuench is located as fixed mounted in the busbar compartment. That is why only a single SIQuench per bus section is required and enough for the mentioned protection. As of today, SIQuench is available as a complete integrated solution into the internal classified air-insulated medium voltage switchgear type NX Air up to and including 17.5 kV and 50 kA. When it comes to decision making, there is unfortunately no one-fits-all solution. Each business has its own facts and figures. Accordingly, the optimum decision shall be given by you, considering those specifics by not forgetting the priorities we agreed on a couple of slides back. First, protect the personnel to the best we can. Second, maximize the availability of the equipment and related connected processes. Then, raise these practical but thought-provoking questions to yourselves, like, is an unplanned downtime an option for me? How would an arc flash impact my personnel and my profitability and my reliability and my corporate image? Go through all these possible consequences. Then think for the next step. Which one to choose based on your honest answers? Either going for the solutions that have nothing to do with real life, or going for what the standards allow you to do, or going beyond the standards. It is worth mentioning the explicit benefits of the solution. First is the minimized downtimes due to prevention of the damage given to the equipment. This not only leads to increased availability of the processes, but also help eliminate related penalties. Second is elimination of the impacts on the surroundings, which in many cases being underestimated during risk analysis and life cycle related expenditure calculations, but actually takes a big role on the costs after an arcing fault. Overall, it is the reduced OPEX supporting the business. Last but not least is the improved safety, which is beyond the one defined in the standards, as it not only supplies safety under normal operating conditions, but also for maintenance maneuvers. Thank you for your time and attendance. Today has a completely different significance from our topic. Today is the 4th of May, the Star Wars Day. This has not been arranged consciously, but purely a coincidence. But that cannot prevent me from closing the session by relating both topics. May the safety beyond the standards be with you. Now, the speech is yours with your questions.
Thank you, Kerem. Yeah,
You're welcome.
was way beyond what I already know. And I even learned something more in comparison with the first session. So it's always good to join in and see stuff maybe twice. And we have a lot of questions rising. And so thanks for taking part in the presentation. And we'll directly start into the question and answer round, either with you, and we already know that we also have Deja in the background in the chat. So you might see some of the questions will be answered by Kerem and other ones might be answered by Deja. And if you wonder who is ND or AKV, if I read that, I just see the initials. I do not see names. So the first question is, Is arc flash device a mandatory requirement nowadays? What is the lowest capacity that the arc flash device can be considered?
As of today, as per the available standards, it's not a mandatory requirement, but purely an optional one. But as you see, after seeing the benefits, I guess without considering whether it's mandatory or not, our customers will go for it. I hope so. This is logical. And the other thing, the minimum rating for this is, as far as I know, a requirement from the standards in the ANSI market, from UL. This is not a requirement from the IC. Therefore, we have no defined minimum current for the device itself. So as soon as the supplier has defined this, this needs to be included as per the UL requirements in the rating plate of the device. But for IEC, this is not a requirement. So as of today, our development, the standard has been developed as per IEC. Nowadays, our colleagues from the US has initiated the UL certification process. And maybe by the end of this process, the questioned rating will be available.
Okay, thank you.
You're welcome.
Then it's not really a question, but taking care of the importance, are quenching importance in GIS system? So I don't know. Yes, we have air insulated systems here. Now somebody wants to emphasize probably that it's also important in GIS systems, but I guess that's something different, right?
Yeah, GIS compared to AIS for sure is much more protected from the environment with much more insulation and the gas encapsulation and etc. But it doesn't mean that there is 0% probability for an internal arc fault. Therefore, why not? It would be the case, but this needs to be raised to the colleagues from GIS.
Yeah, kind of a different topic,
yes,
also
definitely.
within our house. But we might take the question with us and contact them that it's also a question there, surely, to protect the equipment, right?
Sure.
And not only the equipment, but in case of GIS, also personnel, like we have it with AIS.
Sure, but what I would add as detail, theoretically it's possible to locate SIQuench in any medium voltage application, regardless of whether it's AIS or GIS.
Okay, good to know that. Thanks. And then we have the question from AKV, how to calculate arc value? Does it depend on different types of interrupters?
By saying arc value, should I understand the incident energy released during an arcing fault? If this is the case, there are some simulation methods for this. So the basic one you can go for is I²T for sure. But it requires, I guess, a simulation. This is
okay.
All I can give a feedback.
Yeah, so we try to answer the questions the best we understand them here in the studio. And if you have the feeling that your question is not properly answered, contact our experts. That's why we are here and why they are here. And we'll continue the journey through the questions because there's one from EB. The questions are, it's even two of them. The first is, what IC standard covers this kind of arc quenching devices?
There is no IC standard, a medium voltage IC standard available as of today defining such a product. Therefore, for our developments, we rely on the standard for the earthing switches.
Okay, good. And the next question is, please clarify where the SIQuench is mounted. Independent column or maybe integrated into incomer or busbar PT?
As per our current offering, we mount the SIQuench as fixed mounted in the busbar compartment. From our perspective, this is the most cost-efficient way of doing this. And by doing so, you require only a single SIQuench per bus section, regardless of the number of panels.
Cool, yeah, that sounds like an plausible solution. And next question is from Geir, do you have an amendment to that?
Yeah, in fact, I want to a little bit give you time to breathe. It was really intensive discussion till now. Please take your please take your certain seconds. The thing is, yes, first of all, thanks to all questions and interest you have shown or we have seen from the attendees so far. In one hand, I was keeping an eye on yourself. On the other hand, I was keeping an eye on the questions. Maybe it's right time to now combine maybe answering the questions together. One question I found is maybe that was the point, Kerem, where do we install the SIQuench? In fact, I have just written SIQuench is placed on the bus bar of a panel, and how many SIQuench solutions do we need per bus bar section? Maybe here I want to combine. If there are any other questions from there, Mihaela, let's also combine it. One SIQuench per bus section is enough. And if you have two incomers, they can also sort into one SIQuench. But if you have a coupler system where two different bus sections are combined with a coupler, then we may need two SIQuench, as mentioned earlier, one SIQuench per bus section. We advise normally placing the SIQuench in the incomer panel. There are some certain details about placing of the SIQuench in a panel, but let's not dive into all these details now. Let's pick up another question. Kerem, here I believe maybe we also answer this question together. One question is related to what components do we have as Siemens make and what components do we have as non-Siemens make. Here also, in line with this question, there was one question, 5 milliseconds is detection time or total operation time. I think it's worth mentioning because it's the unique feature of SIQuench, which really enables customers or end users to benefit from. Let's start with reaction time.
This 5 milliseconds is the total activation time, which means starting from the ignition of the arc till short circuiting of the device. This is the total chain timing.
I want to hear, and I wanted our attendees to see this from you, that 5 milliseconds is not only our, let's say, proposal, it was also tested with the configuration. Therefore, 5 milliseconds, in case of an arc, the total reaction time is seen and conducted. Kerem, let's talk about the components of the system.
Okay, there are three components of the system of the application. First is the switching devices, the SIQuench itself. Then there is a dedicated controller we call SIQuench controller. It's mainly a capacitor bank, which is powering up the solenoids inside the switching devices. But it also has status tracking and health indication features, which you can communicate with a SCADA system, with a local PLC, or wherever you wish via hard wiring. And the other component, of course, we need to first detect the arc itself. Therefore, there we use an arc flash protection relay with connected point light sensors.
Yeah, here maybe it's also worth mentioning because it's also answers some different questions from different regions. How do you ensure a SIQuench system is reliable and how it works so safe? Kerem, SIQuench control you mentioned, it energizes the necessary power to the quenchers, but as well, it logs operation of the SIQuench. So how many operations we have can be, let's say, learned from this SIQuench controller. So it has also a log function. In addition to that, maybe it's also answer to many of questions I see on the flow. SIQuench system has also a self-monitoring feature, which means either the point sensors themselves and the arc flash relay connected to them is self-monitored. Additionally, SIQuench on top of the bus bar with the SIQuench control is also self-monitored. In case of any problem, it's also telling you, hey, take care of me. So, Kerem, here, the thing is still I keep an eye on the questions. Maybe I place the question and you take the answer here. I try to see more questions. How does SIQuench sense the current?
Okay, so as I've told, we not only rely on light for detection of the arc, but we also await for an overcurrent signal. This signal is taken from the CTs of the incomers. If there are more than one incomer, of course, we need to sum up the feeding current. So for this purpose, either we can go for a summation CT, which will be located in the low voltage box of our switchgear, or we can increase the number of main arc flash protection units in order to multiply the connections, the inputs for the current inputs. Each arc flash relay, the main arc flash relays has 4 current inputs, 3 phase currents, and 1 core balance current input. So by utilizing these inputs, we get the overcurrent signal.
Thanks. Still, I want to repeat my thanks to attendees. There are nice questions. One of them is I want to take immediately. What is the benefit of Siemens SIQuench solution? I don't want to use the name, but through competition. Here, we may say 5 milliseconds is the overall operation time. And Kerem, you can reflect the details, but reusability. Closing up to 5 consequent full fault current is the main benefits you may reach with the Siemens SIQuench solution.
That's right. When compared to the competition, our unique feature is reusability. The other naming is resettability. So SIQuench can withstand 5 consecutive internal arc faults with the full rated current of the switchgear.
Kerem, I remember your praise on those days where we were developing this SIQuench. You want to be different. You want to be separate or unique on the feature, because we know some certain such devices need replacement after single operation. So I remember headache we had. You were asking for, hey, why do we need to change the element after one operation? So it's good that you had the pressure, and now it's really nice to release 5 times reusability is a really fantastic feature of SIQuench. Any additions?
Go on, sorry. Sorry.
No, on the other hand, maybe one addition. Maybe you can tell the story about this testing, because, in the testing, we did not only test the performance of the sensors or the performance of the arc flash relay, we really tested the performance of the overall system, what we are talking about, from sensing of the arc till SIQuench is earthed. Therefore, this was a nice effort worth spending, because it takes really a switchgear into a different level.
Sure, there. First, for the development of the device itself, we had separate testing sessions, type tests for the standalone device. And when we succeeded in this, our first integration was in NX Air, up to 17.5 kV and 50 kA. Therefore, we integrate the device into NX Air, and we conduct many of the tests specific to the switchgear as per IEC, also with an integrated SIQuench. And there, we have proved the performance of the device in parallel.
Thanks. Again, here, one question maybe we need to pick up is SIQuench necessitates an arc flash relay. Question is, here, are we limited to use only arc protection relay, arc flash relay, or are we having the freedom to use different protection relays? In theory, yes, different make arc flash relays can be used. But as just short before mentioned by Kerem, the performance of the overall system, which is really a nice feature of SIQuench, operating less than 5 milliseconds, is only confirmed with that completely together tested optimized solution. In theory, a different arc flash protection array may be used, but we cannot anymore guarantee that same limited duration. Additions, Kerem? Or
I have nothing to add. That was clear.
Kerem, here one question. I still want to pick up others. Maybe you give me time this time. Here, is it possible to use SIQuench in brownfield projects or in non-Siemens switchgears?
There, as soon as the technical requirements from relevant standards are kept, SIQuench can be located theoretically into any medium voltage application. So yes, it can also be used for brownfield applications as well as on non-Siemens branded switchgears.
And while Deir is checking for more questions, I see one that I find interesting, even if I do not understand the details there. But the question there was, what will protect the upper zone in busbar compartment in the area before the arc quenching devices?
There, this is your expertise area. Without having an arc flash protection, what are the old conventional methods for such protection?
Yeah, the thing is here, so-called intertripping signals is sent to upstream circuit breaker. So even this question was, I believe, in the morning session. It popped up a little bit earlier. What happens if the fault is in the cable compartment of the incomer? At the end of the day, like previously explained or explained by Kerem, we place light point sensors in each compartment of the medium voltage panel. If the fault is in the cable compartment of the incomer, it is still sensed by the arc flash relay. Here what happens is CB tripping signal is both sent to incomer and also the upstream circuit breaker, which is feeding our, let's say, system. Therefore, it also helps getting rid of the fault.
Cool. Great to know. So you think about everything. I mean, kind of like expected, but yeah, you do. Cool. Do you want to proceed with one?
Yeah, the thing is, maybe we need to mention we are not only limited to this time, but nice questions are coming up. Maybe, Kerem, still one question is, can we retrofit SIQuench into oldly delivered Siemens switchgears or non-Siemens switchgears? Here, once again, I let you go checking for the other questions.
There, as mentioned earlier, as soon as the rules are followed and applied properly, yes, SIQuench can be located in any medium voltage application. So our strategy for such business as of today, for such modernization or retrofit business as of today, either going through our customer center worldwide, or go through a selected partner who has both the mechanical and electrical expertise on arc flash protection. Therefore, our attendees can get in contact with their local Siemens sales offices, and for sure they will be guided for the best channel as per their specific requirements.
Cool. And I think Dale checks for questions. I've one for you. Is the SIQuench complementary to IAC, AFL, and brackets R classification, or is it relevant to have SIQuench on a non-IAC switchgear?
But yes, it's an optional on top of an IC classification. So as per IC, having a SIQuench does not allow you to automatically have an internal arc classification. First, you should fulfill with your switchgear design the internal arc classification as per IC with the defined durations of 0.1 second or 0.5 second or 1 second. Then SIQuench comes as an additional player, which is carrying your switchgear beyond the requirements defined in the standard.
Cool. Yeah, I'm always glad that you understand the questions much better than I do. I just pick them and think they are interesting and you understand them. That's why we have the expert here in the studio. And this one is something I think it's interesting. At least the answer will be interesting for me. Is there an end-of-life indicator on the quenching device?
Not physically directly on the quenching device, but on the SIQuench controller, which is located on the low voltage compartment as flash mounted on the low voltage door. There is a USB input, and by using this USB input with your laptop, you can get connected to the firmware of the device and can read how many times it switched either under load or without load. So this data is readily available, but in order to access this, you need to get connected.
Oh, okay. So no transfer to any kind of control center, but I have to go there.
Yes.
But in case of such a fault, I have to go there nonetheless, because there might be something happen to the compartment, right?
Actually, by having a hardwired connection to a digital relay and by activating a disturbance recorder on the digital relay, you can also count how many times it switched. So you can refer to this historical data as well.
Okay, and then I can have it somewhere remote, read it from any kind of...
Yeah, this data will be available on your disturbance recorder.
Great to know that. Thanks. Yeah, that was one of those interesting questions, and that it's great to see your participation there. We still have time for questions, and we take more of them. And then let's see. There, do you have a dedicated question you want to raise?
Yeah, I tried to find some certain questions which popped up for the first time. This one is looking like brand new. So, is there any interference in the use of SIQuench and limiting fuses? Here, maybe Kerem, we need to make a separation. Fuses are normally used in series of a current path where some certain devices which do not have short circuit capacity, fuse will behave for them. Here we need to separate. SIQuench does not make a breaking function. SIQuench, just the opposite. It makes a earthing, or it makes a closing onto, let's say, earthing. Therefore, it's two different issues, and fuses are not to be used on the path of a SIQuench, because otherwise, in case of a short circuit, it may melt, and it may really block the usage of SIQuench. Two different procedures, two different working philosophies. So,
thanks.
No issues.
Okay.
Here, Kerem, without mentioning our competitors, there were also some certain issues still questioning what makes SIQuench a little bit separate compared to others. Maybe this could be a chance also to mention this for those who were late or in your presentation.
So both the competition and we have the similar method for quenching the arc. We create an intentional bolted short circuit, so we are diverting the open arc into a controlled bolted short circuit. This is the same also for the competition, with the competition. The unique feature we have, our device can withstand 5 consecutive internal arcing faults without the need for replacement and maintenance. Just remember there, we are pushing on the benefit of extended availability of the processes and the equipment, the switchgear itself. So just imagine if you need to replace your component after an internal arcing fault, how are you in a position to talk about extended availability? You need to do something. With SIQuench, this is not the case. It can withstand 5 consecutive internal arc faults without the need for replacement and maintenance.
Yeah. Here, Mihaly, I've seen maybe 2 different questions, and also with Kerem, maybe we can combine the questions and generate a one common answer to those 2 questions. One is, let me see here. Yeah, after 5 times of operation, what's the risk involved if you do not replace a SIQuench? A very strange question, which we faced for the first time. And second, do we need to remove those gas release channels at the top of the panels? So here the issue is, once again, colleagues, after 5 operations, or even without a SIQuench, as long as you are using a internal classified type tested switchgear, as mentioned earlier by Kerem, risk of a arc is low, but not impossible. Therefore, if you use that internal classified switchgear, risk of injury for an operator is very limited, but SIQuench is really limiting the danger on the components, on the equipment itself. Therefore, with or without SIQuench, please still fulfill the expected installation guides and requirements of the product. Kerem, in which way you will add to this issue here?
The risk here is it may not function in the next internal arc fault, where you may not be getting the additional benefits which you are looking for. But still, your switchgear will remain with an internal arc classification. This is not a pre-requirement, as mentioned. And coming back to the question of the flaps, whether they need to be replaced or not, this purely, of course, depends on the level of fault current which you face. If it was low, there may be no need. If it's too high at the end, on the edge, they may open up, the flaps may open up, but you may simply shift this replacement activity to the next planned maintenance activity. So no need to wait for closing or replacing the flaps in order to re-energize your switchgear.
And while we are in this vivid discussion, I've just seen that we are around this 45 minutes. We invited you to join us here. I think we have so many questions in the row, so I would just prolong the question and answer route for a short while, take some more of the questions. But if you have other dates right now, it's okay if you leave, but we kindly invite you to just stay with us. And one question that's once again raises my attention is, and that's a tricky one, I think, because it's how is the price increase in the protection philosophy when using SIQuench?
I guess during this session it would not be proper to talk about the pricing, but for sure we got your emails, so I will be sending you an indicative pricing info as per your query, for sure.
And I think the question is not only how much do I have to pay for it, but as I understand it, you get this value of advanced availability, of the protection of your device itself, the protection of stuff. So yeah, how much money is Vivid Life valuable? So yeah, I mean, that's why you put in this decision slide. I remember that with these arrows there, take your path through the decision, right?
Sure, and as some simple indicative data, just refer to the price of your single feeder. Just assume that this is the feeder where you have the internal arc fault, and you will be losing it for sure. Maybe you need to replace it. Therefore, take this as an indicative price, what you will be losing when you don't have the SIQuench itself.
And then I guess it relevates the price that we have to pay for a SIQuench. I have no idea what it is.
Considering that you need a single SIQuench per bus section, that yes, it will compensate itself.
I think so. Dayer, do you have one last question you want to pose?
Maybe it's worth re-mentioning. Is it possible to have single device on a double bus bar system, or necessary to have two? Here we also, this was also part of Kerem's presentation, I believe. We let's say one SIQuench per bus section. So if you have two bus bar system coupled with coupler or double bus bar system, then better to use two SIQuench. So I've seen this as a last question.
Thanks, Dayer. So thank you, Dayer, for being the chat partner in the background. Thank you, Kerem, for all these answers here. Thank you out there for all these questions. We still have open questions in the row. We do not have the time to answer all of them, but be assured, we will get back to you via email. We will answer your questions. And if questions come to your mind later, just continue and contact our specialists, either the two here, or go to siemens.com/SIQuench and contact us there. The access to the recording of this presentation and of the slides will also be sent to you. So if you think, oh, I think I missed something, just visit the recording. So thank you once again for your active participation. It was my pleasure to guide you through this hands-on session on SIQuench. And remember, we learned about this highly increased equipment and process availability, the definite minimized duration of downtime, and therefore drastically reduced economic losses. And not to forget personal safety, so increased safety outside the normal operation conditions. I'm now looking forward to meeting you soon in one of our next webinars. Stay safe, take care of arc quenching and medium voltage applications, and see you in one of our next webinars. Take care of your equipment, and goodbye for today.
Thank you. Bye-bye.